In the past 2 decades, astronomers have made a truly revolutionary discovery that the cosmos is not only expanding, but is doing so at an ever faster rate. The discovery of the accelerated expansion of the universe was awarded the 2011 Nobel Prize in Physics. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESOcast. In this episode, we're going to find out how astronomers learned that the expansion of the universe is speeding up, and why this finding is so important not only for our understanding of the cosmos, but in fact for all of physics. Now, this discovery was awarded the 2011 Nobel Prize in Physics, and observations from ESO's telescopes in Chile played a significant role in this breakthrough.
The universe we live in was created in the Big Bang some 13.7 billion years ago. Ever since then, the universe has been expanding. And for decades, astronomers have wanted to learn more about the nature of this expansion. For a long time, there were 2 main ideas. Either that the expansion would gradually slow down and would ultimately come to a halt, after which the universe would start to contract towards a big crunch, or that the cosmos would continue to expand forever.
But how could astronomers find out which of these models of the universe is the correct one? Well, one of the simplest ways of doing this is to accurately measure distances to very far away galaxies, and then to compare these measurements with the predictions from these models for these particular galaxies. Now, the comparison between the measurements and the predictions tells us which of the models is the right one. But how does this work? How can astronomers precisely determine these huge distances across the cosmos? Well, stellar explosions, or supernovae, play a key role here.
Supernovae are rare cosmic events. They are exploding stars. There is a certain type of explosion known as a Type 1a supernova, which is ideal for measuring distances in the cosmos. These supernovae are very bright, which means they can be seen even in distant galaxies. And what's more, their intrinsic brightnesses are always the same, meaning that their distances can be inferred from how bright they appear to us from Earth. By the 1990s, 2 separate research teams had begun to carefully observe these exploding stars. For their studies, astronomers partly used telescopes at ESO's La Silla Observatory in Chile.
Observing extremely distant supernovae in the mid-1990s was extremely challenging and exciting. We at ESO used the 3.6 meter, the NTT, and the 1.5 meter telescopes to observe these high redshift supernovae discovered at the nearby Tololo Observatory. In those days, 15 years ago, we were actually counting literally every single photon. This was a beautiful experiment to be part of because it was extremely challenging. The critical component of all of this is, of course, to realize that we did not set out to find the accelerating universe. So watching a new paradigm in physics establish itself has, of course, been very interesting, and it's been great fun.
Once we had established that the distant supernovae were too far away for a universe that was dominated by gravity, we had to go back and measure this again. So the accelerated expansion that we measured with the first set of supernovae, and which then was translated very quickly into a new component for cosmology, dark energy, we had to confirm that result. And what we did, we asked for VLT time, like other groups as well. Several other groups did the same thing, to confirm what we had measured, to get better data with a bigger telescope, and to get a better sampling of the supernovae themselves.
The discovery of the accelerating expansion of the universe was one of the most unexpected and important of the last decades. It was so unexpected because up until that point, everyone believed that the expansion of the universe should be slowed down by the attractive force of gravity exerted by all of the matter in the universe. But as it turns out, the universe is in fact much more interesting than that. But why is this acceleration so important? Well, as far as we know, there are two possible explanations for the acceleration. The number one explanation is that nearly 3/4 of the universe consist of some form of this mysterious dark energy. Now, dark energy is so mysterious because it exerts negative pressure. That's pretty exotic stuff. The number two explanation is that there's something wrong with our understanding of gravity. In other words, that Einstein's theory of general relativity is not quite correct. Now, in either of these cases, we are confronted with completely new physics, and that's why this is so important and why this discovery was awarded the 2011 Nobel Prize in Physics. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.